Hey guys, welcome back to my YouTube channel. Firstly, I'd like to apologize for not posting in such a long time. I've been working on multiple projects and I really just didn't get a chance to do any videos for YouTube. That being said, I will respond to all you guys' comments and I'll try to do the stuff that you guys asked in the coming weeks. So with that, I've just created a small project that I'd like to share with you guys. It's changing or converting numbers into words, and this is how it works. So you can input any number into this input field and click the convert button, and there you go. So I've done it where it works up to 999,999,999. So you can probably do some more coding and take it up to a billion, a trillion, and so on. So if I do 1 million, it will display 1 million. If I want to display 1, 2, 3, 4, 5, 6. Now you could take this application further and do a lot of error checks to check that if there's any spaces when the user types in a number, you can remove that, then run your code. Or you could actually check if the user doesn't even enter any number and clicks the button, it shouldn't do anything and it should prompt the user to enter a number and a positive number. If the user enters a negative number, you can obviously add on code to do some error checking there. But for now, it's just a simple application just to get the ball rolling. So let's get started.
Okay, cool. So I've just started off here with a simple scene. I've already set up the UI for the scene so that we can not waste any time, but I'll just run through the UI quickly with you guys. So we just have a text heading here. We have a text to inform the user what you want them to do. We have an input field. That's a Text Mesh Pro. We have a button, and we have a Text Mesh Pro text holder where all of the text is going to display when the conversion is done. So let's get started. So what we're going to do now is create our C# script. We're going to right click in the assets, go to create, and we're going to create a new C# script. We're going to call this numbers to words and hit enter. We're going to double click to open it up in Visual Studio. Okay, cool. So once this is opened up, I'm going to get rid of the start and update function because I don't need it as yet. And the first thing we're going to do is, or the first thing we're going to need is a list to hold all of our text that we want to actually display. So we're going to need one for the ones, one for the teens, and one for the tens. So ones being 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, teens being 10, 11, 12, 13, up to 19, and then tens being 20, 30, 40, 50, 60, and so on. So let's start with that. So I'm just create a list. It's going to be of type string. I'm going to call it ones. It's going to be equal to new list type string, and I'm just going to fill in these values. So just for the purposes of this video, I'm not going to type all of these numbers out. I already have it typed, and I'm just going to copy and paste it in. Okay, the next thing we're going to need is a number, and I'm just going to put it up here. So we're going to need a number that the user enters. So we're going to only deal with positive numbers, so we'll say int positive number, and we're going to just set that equal to 0. Cool. The next thing we're going to need is a output. So what we want to output after all of this calculations is done, let's just create our variable now. So we'll create a variable called words, and we'll just set that equal to null for now. Then what we're going to need is we're going to need some sort of place to display this words, right? After this computation is done, we want to obviously display it in a Text Mesh Pro element. So we can just create a new Text Mesh Pro. I think before we do that, let's import that library. So we're going to say using TM Pro. Now we can say Text Mesh Pro UGUI, and we'll just call this display words. Awesome. So what we can do now is we can create our function for our button. So let's do that. We'll say, because the reason we're actually creating a function for our button, it's going to be attached to our button so that when we do click the button, we want certain functionality or logic to take place. So we'll just create a public void function and we'll call this convert. Let's just bring that down to lowercase. Awesome. So the first thing we want to do is obviously get that number that the user enters. It's going to be of type string when it comes in, but we want to convert that to an integer. So we can say positive number is equal to int32 dot pass, and we want to pass in the positive number. Okay, before we do that, we didn't actually create our field for our TextMesh Pro input field, so let's do that. We'll say public tmp underscore input field, and we'll call this positive number input field. Cool. So we'll just copy this variable and we'll paste it in there, and what we want to get out of that variable is the text component, because that's where the user is going to enter the number. Then I'll just close it off, and the reason this gives you a squiggly is because we need to add in a library. So you can control dot and it says using system, you just click on that and it will add the using system library on top there. So that looks nice. Now the next thing we want to actually do is we want to display all of this information. We want to display all of that information here, right? So in this TextMesh Pro text box, so we can head over to our script and we can say display words dot text, which is the text holder, but we want to actually put in some text in the text component. So we'll say dot text is equal to, now what is it going to be equal to? It's going to be equal to something after all of the calculation is done. So obviously we're going to need another function to do that calculation for us, so we can just create that function here now, and we'll just pass in the positive number there. Okay, so the reason it gives us squiggly is because we don't actually have that function. So I'm going to say string, and I'm just going to copy this function name, paste it here, and this function is going to take in a int value. Then I'll open close, and obviously I need to return something. So what I want to return is words, right? Whatever's going to be here, that's what I want to return. Cool. So let's get started. So now we can start with our first check, right? If the number is below 10, so from 0 to 10, then what we want to do, so we can say if the number is less than 10, and obviously as I said before, you guys can take it a step further and check whether the number is greater than 0 and less than 10, but I'll leave that up to you. Then we need to do the check here, but we need to create or we'll want to create a function to take care of this, right? So we can call this function get the units, and we'll pass in that value in there. Now obviously we need to create this function, so I'll just copy that name, I'll come down here and I'll create this function. I need to return something, so I'll say string, paste that name in, and obviously this function is going to take in that number, and it's also going to return words. Cool. So what do I want to do when the number is less than 10? I just want to say words is equal to, and I'll call the ones array or the ones list and pass in that number there. So let's see if we know what's happening. So the number 6 comes in here, it goes down here. Is 6 less than 10? Yes, it gets into this function. We come down here, words is going to be equal to 6 is going to come in here, and 6 is going to be displayed there. So we go back to our ones list, and then we can start here. I will say 0, 1, 2, 3, 4, 5, 6, and there you go. So words is equal to 6. We're going to return 6, and we're going to display 6 out to our UI. So let's save our work, get back to Unity, and we can try this out. So we'll hit play. Let's enter that value 6. Let's hit convert, and there you see a nice display printing out 6. Cool. You can just try this a little bit more. 7. You can try this at 2, and you get the picture. Awesome. So we can head back into our Visual Studio Code, and we can do the next check. So now we want to check if the number is greater than 10 but less than 20. So we can say else if the number, and we don't really need to say greater than 10, less than 20, because that this will take care of that. So let's just say less than 20. Then what we want to do is we want to create another function to do all of this work for us. So we'll say get the teens. So that's 11, 12, 13, 14, 15, 16 up to 19. But we're just going to say get the teens. We're going to pass the number in there and we're going to close it off. We'll copy this down here and we'll create our new function. We'll say string because we want to get something back. We'll paste the function name, and obviously this function is going to take in a int value once again, and we'll just keep the same naming convention. It needs to return words. We close that off. Now what we want to do, we're going to say words is equal to teens array or list, and we're going to say the number minus 10. And why we're doing that is, so let's do an example. So the number 15 comes in here. Is 15 less than 10? Nope. Is 15 less than 20? Yes, it goes in here. It calls that function. We come in here. 15 goes into this list, but it's minus 10, right? So this is going to evaluate to 5, and it's in the teens list. So we're going to go up to the teens list, and we're going to see 0, 1, 2, 3, 4, 5. There you go. That's what it's going to output. Cool. We can save this here, and we can head back to Unity and test this out. Enter 15. And there you see, we can do a couple more tests. And guys, this is a manual testing. In my next video, I'm going to set up some unit testing and show you guys how that works to automate our testing. It is a little bit more work up front, but it really helps in the long run to test your code. And unit testing is one of the best ways to do that. So we can test at 19, and you see it works fine. Cool. We can do our next check. Let's save our work. Head over back to Visual Studio. Now we want to check if the number is greater than 21, but if it's less than 100. So we'll do an if else or an else if, and we can say if the number is less than 100, then what we want to do. Now we're going to say let's get the tens. So that's like 20, 30, 40, 50, 55, 65, and all of those numbers in between. So we can say get the tens, and we'll pass in the number through there. We'll close that off. Once again, we'll copy the name of this function, head over down here, and we'll create our function. So it's going to take in a int. It needs to return words. Cool. So now what we want to do, we want to say words is equal to the tens list, the number divided by 10, right? So that's for the first part. So when the number like 30 comes in here, 30 will come in here, 30 divided by 10, which is equal to 3. It's going to go up to this unit here, or the tens list. It's going to say 0, 1, 2, 3. It's going to display 30. But if the number is 33, for example, we need to take care of that as well. So how we're going to do that is we're going to say plus the number modulus 10 is not equal to 0, right? And I'm just going to use this question mark. Yeah, basically what this allows us to do is write an if statement in one line, right, for a simple explanation. So whatever's on the left is your condition. So if this is true, then what we want to do, we want to display a space plus. So first we want to do a check, and if that check is true, then we want to display some units, right? So like 30, we took care of the 30. Now we need to display the 3 part, but we already have a function that does that, so we can just call that function. We can say get the units, and then we obviously need to get the remainder of this number, right? So we can say number modulus 10, and then if that's not true, we don't want to display anything, right? So if it's just 20 or 30, we just want to display this part, and we don't need the rest of this, so we'll just display nothing. We'll close that off. Okay, so let's run through what we just wrote here. So if 33 comes in, 33 will come in here, 33 will come in here, but this will only evaluate to 3. right? So as I said before, it will go up to the tens list, it will get this 30, it will come back down here, this equates to 30. Now we need to take care of the rest of it. So 33 comes in here. This modulus means that it will return the remaining value. So 10 goes into 33 three times with a remaining value of 3. So this entire expression here becomes 3. Is 3 not equal to 0? This statement is true. So this means if this is true, do this. And what do we want to do here? We want to leave a space, and then we need to get the units. So once again, 33 comes in here, modulus 10, this answer is 3 because that's the remainder. It goes up, it fetches 3, and this entire thing becomes a space and 3. So our final answer will be 33. So we can test it out. We'll put 33 in there, and there you see it, 33. We can put 55, you can put 69, you can put 98, and you see everything works fine. Alright, now we're ready to do our next check. So for our next check, we want to say let's do a check for all of the numbers over 100 but less than 1000. So we can say else if the number is less than 1000, then what we want to do, we want to create another function. So we'll say get the hundreds, and this will take in the number. We'll copy this function name, we'll go down here and create our function. So we'll say string function name, and it will take in a number. It needs to return words. Right, so now what we want to do, let's just make some space there for us to work with. And for the sake of this, because we're going to be displaying this the 100 word, let's just create a constant. Let's create our constant up here. So we'll say const string 100 text is equal to, obviously we need a space there, and we'll say 100. We'll close that off. Cool, so now we can use that instead of just typing 100 all the time. So let's start, right? We want to do the first check in this. When a number comes in as, so there's a couple things that we need to take care of this with regards to when the number is greater than 100 and less than 1000. We need to take care of when the number is like 100, 200, 300, 400, that's all the hundreds. And we need to take care of when the number is like 101, 111, 201. We need to take care of that, and we need to take care of all of the numbers that's like 125, 135, 985. So there's 3 different things that we need to do. So let's do our first check. We're going to say if the number modulus 100 is not equal to 0, and the number modulus 100 is less than 10. Okay, for example, firstly, let's say if 101 comes in here, 101 will come in here, 100 goes into 101 one time with the remainder of 1. Is 1 not equal to 0? That is true. Then it comes in here. The same thing, is 1 less than 10? That is true. So we can do something in here. And what do we want to do? We need to display 101, right? So we'll say words is equal to, and we can obviously we have a function to display the units already, so we can use that. We can say get the units, we'll pass in the number, and we'll divide that by 100. So when 100 comes in here, or 101 comes in here, this will evaluate to 1. It'll go to this function, and it'll put the 1 in here. We go up here to this list, and it'll display 1, 0, 1, right? Then we obviously need to say it's 100, right? So we can just output that text, which is 100 text, and this text here is obviously the constant that we created up here, right? Then we obviously need to display the other part of it, which is 101, right? So we can leave a space, and we can obviously get that second part, and we have the function to do that. So we can say get the units. We'll pass in the number, and we'll say if the number is, well, not if the number is, the number modulus 100, which will only return that one, that remaining one, and that's what we want. So we can display 1 100 1, and that's what we want. We'll close that off, save our work. Let's head over back to Unity, and let's test this out. So we'll hit run, say 101, and there you see it. And we can do all of this up to, okay, let's try 109. That works fine. Let's try 209. That works fine, and all of that will work fine. But once we start going to like 110, you see that our code will break. We can't do 210 either. So now we also need to take care of that. Okay, cool. So let's do our next check. So we can say else if the number modulus 100 is not equal to 0, and the number modulus 100 is greater than 10, right? And we're going to do one more check, and we're going to say if the number modulus 100 is less than 20 as well. So we're just catering for that in between value, right? So that's like the one in all the teens in between, right? So like 200, 119, 115, 215, 316, all of those things. So let's take care of that. So we'll say words is equal to, and as we know, we can just call the get the units function to get the first part of it, and we can pass in the number divided by 100, and we need to display the hundreds text. And the next part, we need to display a space, and we need to get the rest of the value. So we got 100, 300. Now we need to get the teens part, but remember we already created a function to get the teens, so let's use that function. So now we can call the teens function. So get the teens, and we just need to pass in here the number modulus 100. We can close that off, save our work, and let's go and test that out. So now we can test 111, 115, 219, 917, and that works fine. But remember, we still can't test 110, 220. We still can't test those numbers because we haven't taken care of it. So let's take care of it now. So we can say else if, or we don't need to say else if, we can just say now else. So obviously that will take care of everything else. When this fails, it will take care of all of that. So we just want to display the units. So that's your get the units function. We pass in the number divided by 100. We add in our hundreds text, and now we're going to do a similar thing to what we did here. So we're going to say if the number modulus 100 is not equal to 0, then what we want to do, we want to display a space plus that number, and we can just call this function again. So we can just call this function again because that remainder is going to go in here, and then it will just continue on its own, and I'll show you what I mean by that. So we'll just call this function again, convert numbers to words. We'll say number modulus 100, and if it's not true, then we obviously just want to display nothing, right? And let's close it off. So let's run through this last part. So just say the number 110 comes through, right? 110 will come through here, 110 will come through here. This will evaluate to 1. So we got the first part, we got the second part, that's 100. Now let's take care of that 10. So we're going to say the number modulus 100, which will evaluate to 10, right? Because that's a remainder. Is 10 not equal to 0? That's true, so we need to execute this part of the code. So we leave a space, and we can just call this function again. So the number modulus 100, so this will evaluate to 10. So 10 comes in here, 10 goes down in here, and we get this value because this function takes care of that, right? So we can head over back to Unity. Now we can test this out. So we can put 110, and there you see 110. We can do 250, we can do 970, and you see it works nicely there. Cool. So let's do the next part. Okay, now let's take care of all the numbers greater than 1000 but less than 1 million. So we can say else if the number is less than 1 million, that's 6 zeros, then we need to create another function. So we'll say get the thousands, right? We'll pass in that number. So we're just going to copy all of this, and then we're going to create our function. Let's minimize all of these. I know it needs to return words. Close that off. So what we want to do now, we want to say words is equal to, and we're going to call this function again. Which function we're going to call? The main function, right? So we're just going to call the convert numbers to word function, and we're going to pass in the number divided by 1000, and we obviously need to display the 1000 keyword, but we can just create another constant up here. So we can say 1000 keyword or 1000 text equals to space 1000, and we can close that off. So now we can use this text, we'll display that there, and then we still need to do some more checks for the other parts of it. So if the number is like 1001, 1002, and so on. So let's do that. So we'll say the number modulus 1000 is not equal to 0. Then what we want to do, we want to display a space, and we want to call this function again. And I would say number modulus 1000, close that off, and if it's false, then we just want to display nothing, and finally we can close it off. So what happens here now is, if 1001 comes in here, 1001 goes in here, 1001 divided by 1000, this is going to evaluate to 1. It's going to go up here, it's going to put 1 in there, it's going to come down here, we're going to get the value 1. Then it's going to say 1000, let's miss out that 0. Then we need to take care of the next part, right? So 1001 comes in here, this is going to evaluate to 1. So is 1 not equal to 0? That is true. So we're going to display this part, and we're going to display a space, and we're going to call this function again. So when 1001 comes in here, this is going to evaluate to 1. We're going to go back up here, 1 is going to go in there, we're going to get the units, which is 1. So your final answer is going to be 1001. So we can do that test quickly. We can open up our Unity app, and we can run our code. We can test 1001, and there you see it. We can test 1000, we can test 5000, we can test 700,000, and it takes care of all of that for us. We can even take care of 900,000, 900,000, 999,000, 999. We can even try that. 999,999, and that's correct. Cool. So let's do our next check. So what we want to check finally is, for this video, I'm just going to go up to 1 billion. Right? If you want to go more than that, you're more welcome to. So I'm just going to do another else if the number is less than 1 billion. So that's 9 zeros, 1 2 3 1 2 3 1 2 3, and I'll do an open close, and I'll just create this function called get the millions, and I'll pass to the number there. And while I'm here, I'll just do an else, and I'll just leave that for you guys. So you can say billion, sorry, you can say trillion, and so on, right? I'll just leave that up to you guys. Or you can even do some other checks here. But for now, let's stop at billion, right? Or one before billion, which is 999,999,999, right? So let's get that started. So we'll create that function, and we call this function get the millions. We'll pass or let this function take in a value. We know it needs to return words, and now we can create our function. So we can say words is equal to same thing like up here. What I'm going to do is, just to save time, I'm going to copy this code and I'm going to paste it here. All I'm going to do is change these 1000 values to 1 million. So I just need to add 3 more zeros. 1 2 3 1 2 3 1 2 3, and obviously I need to change this to million text. So I can just say million text. I'll copy this, and I need to create that constant up here. So I'll say const string million text is equal to, and I'll close that off. Cool. So let's just go over it one more time, convert that. That looks fine, and everything looks fine now. Let's head over to Unity and test this out. So let's test our first number, which is 1 million. Awesome. Let's test 535 million. And lastly, let's test our famous number, which is our last number that we're checking for, which is 999,999,999. And let's double check this if it's correct. It's a big number, 999,999,999. And guys, with that, we have come to the end of this video. Hope it helped you guys in some way or the other. Don't forget to hit that subscribe button and hit that bell notification, and also just like this video. It was a bit of a lengthy video, but I hope you guys learned something. Moving forward, we'll try to show more of these maybe lengthier videos, but obviously with some logic behind the actual application, you know. You may use this for whatever reason. You can even take this app further and do a text-to-speech app or anything you'd like to do with it. So I'll see you guys in the next video.